We're going to define trig functions of real numbers. So right now so far we have defined trig functions of degrees and of radians. Now this is important because it's going to the purpose of this is that we're going to be preparing to graph. Okay, so the rest of these videos before we graph is really everything that's going to come into the graphing aspect of the trig functions. So when you graph a function, you represent it with a function name. So f of x, f is a very common way, but you could use g, you could use h. So in the rectangular coordinate system, this is x and this is y, and x represents a real number. Now, currently what we have is that theta is an angle measure and not a real number because it's sine, right? It represents the angle. But what we can do is we can do something really, really simple to help us with that, okay? So what we have is that we look at a circle here, and we're gonna put this I'm gonna draw the rectangular coordinate system on it. And what we do with the circle is that we place t on the right-hand side of the circle. And so what you want to imagine is that when t represents a number, t will have some sort of length, okay? So imagine t like a piece of string or something, okay? So this would be t. And what you do is you wrap, instead of being in a line, you wrap that piece of string around the circle. Now, depending on how long the string is, it could go around and around and around and around the circle, but eventually the string would end. And when it ends, it will be a point on the circle, and we call this point x comma y. So t is the length of the string, and it creates a point depending on when it ends. And if the t was negative, you would wrap the string clockwise, right? So it kind of goes with everything we've already known. If t is positive, you wrap it counterclockwise. If t is negative, you wrap it clockwise. Now, this circle that we use here specifically is going to be the unit circle that we're wrapping it around. And the unit circle is a very simple circle. It just means that the radius is equal to 1. That's all. So because r is 1, when you evaluate your 6 trig functions, remember that before, I'm writing it on the side, that sine of theta was y over r. But if r is equal to 1, if the distance from the origin is equal to 1, that means that sine of theta is equal to y. So this is kind of like when the beauty happens of why we use the unit circle, because when we use the unit circle, it makes r equal to 1, which makes it easier to work with the trig functions. So let's look at our definition. Sine of t is equal to the y coordinate, cosine of t is equal to the x, tangent is y over x, and then the other 3 follow from the reciprocal. Cosecant reciprocal of sine, secant reciprocal of cosine, and cotangent reciprocal of tangent. Let's do a problem. Find the 6 trig functions of t, given that this point is a point corresponding on the unit circle. So this is the key here, right? They have to tell you that. So the unit circle here tells you that r is 1. Once you know that, you can go directly into your y's and your x. That means that sine of t will be the y, cosine of t will be the x, tangent of t will be y over x, so 4/5 over negative 3/5. Dividing by a fraction is the same as multiplying by its reciprocal, so I have 4/5 times negative 5/3. The 5's cancels, and I get negative 4/3. And then the other 3 are super straightforward. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. And we're done. So now we want to relate it to what we've been learning. And remember that really one of the most important part is our golden angles. So what we want to do is we want to take the triangles that I've been telling you to draw over and over again, like draw the triangles, remember the ratios, and we're going to see how that relates to the unit circle. So I'm going to take my 45, 45, 90 triangle. I made this one, and I made this radical 2. Now, I want to place this triangle inside the unit circle. I know that 45 degrees is here. This is 45 degrees. So I want this 45 degrees to match with this 45 degrees. But remember that this has a radius of 1, so that number has to be 1. And if we take a look at it right now, the issue is that I want this to be 1, but this is radical 2. So that's not going to fit in there. So what I'm going to do is I'm going to divide all sides by radical 2. And when I do that, I'm going to have a smaller triangle with the same angles, just a smaller version. This is going to be 1. This is going to be 1 over the radical 2, which rationalizes radical 2 over 2. And on the other side, it's also going to be radical 2 over 2. And what I can do now is I can take this and I can place it in. So when I do that, let's make that a little bit straighter. Here are my legs. And I'm going to have the point here. And remember that on the rectangular coordinate system, the x is the distance at the bottom, and the y is the distance that goes up and down. So both of them are doing radical 2 over 2 and radical 2 over 2. So the point on the unit circle that matches with 45 degrees is radical 2 over 2 and radical 2 over 2. And this makes a lot of sense because this is cosine of 45 degrees, and this is sine of 45 degrees. So it's perfect. So it's just another way of thinking about your trig functions and your golden angles. The really good thing about it is that we can put more than one angle inside. So we can also do it for 30, 60, 90. So let's draw our triangle. So we had an equilateral triangle. We cut it in half. By the Pythagorean theorem, we found that this was radical 3. Now, again, this is too big because I'm going to want to place it inside. And so I'm going to divide all sides by 2. So when I do that, I'm going to have a smaller version, same angles. And again, I want to repeat that you can do that because you're doing it to all sides. And remember that no matter how big or how large you make the triangle, the ratios will always be the same. So when I do this, this is 1, this is radical 3 over 2, and this is 1/2. So what I'm going to do first is I'm going to do 60 degrees. So 60 degrees is 2/3 of the way in. And for now, I'm going to get rid of this little guy so I can have a little bit more space. So 60 degrees puts us right here. So this would be, the whole thing would be 60 degrees. And so at the bottom, my left and my right is 1/2. And my up and down is radical 3 over 2. So the point is 1/2 radical 3 over 2. Now what I got to do still is I still got to put my 30 degrees. So what I'm going to do is I'm going to take this triangle here. I'm going to duplicate it. And what I want to do is I actually want to switch it around. So I want the 30 degrees to be at the bottom. So I'm going to switch the 30 and the 60 together. But remember that if I do that, I have to switch the radical 3 over 2 and the 1/2. So now the 1/2 goes here, and the radical 3 over 2 goes here. Because I have to, the sides have to match with the angles. Otherwise, the triangle is not correct. So now I can take the 30 degrees. So that's going to be over here. So my 30 degrees is going to be right here. And to the left, right, I'm going a positive radical 3 over 2. And up, down, I'm going 1/2. So here are the points that corresponds on the unit circle. So what's really nice about the unit circle, which we're going to discuss in the next video, is that it allows you to see cosine and sine in one diagram. So you see on the left, I have different triangles. I had a triangle for 45, 45. I had a triangle for 30, 60. But now in the unit circle, I can put them all into one diagram instead. So that's what the unit circle allows you to do. It just allows you to put what you've already known into one diagram to represent everything. So we're going to talk about that more.